Hello, my name is Sabrina Berry. I am from Berry Science Lab, and folks, let us start this with a question. Air carries sound waves, and water carries water waves. Then what carries light waves? The answer was believed to be the imaginary ether. Michelson invented something called the interferometer to investigate the imaginary ether. I have good news and bad news. The bad news is that when you look in the textbook, it's like this book, it's very hard to understand. But the good news is that, as you see on the wall here, I invented a new math to support Michelson-Morley's interferometer and Einstein's special theory of relativity. Now let me ask you another question. Does the Earth feel like it's at rest, or does it feel like it's moving? Well, of course, in this building, I feel like I'm at rest, and the Earth is not moving. But imagine this. You are in a car that is moving at some certain speed. Let's say it's at 100 kilometers per hour. And let us say 100 kilometers per hour. Dad's closed all the windows so I don't feel the car moving. But what happens if I open one of the windows? Then I put out my hand. Well, my hand experiences wind. That is wind. So that means the car is moving. If you could stick your hand all the way out of Earth into space, of course that's not possible. So Michelson invented some sort of machine to do that. Now let us get on to the math. Now here comes our math for our new derivation. Okay, step 1, interferometer. The Michelson-Morley experiment. So first, we have to set up a light. We have to set up something like this. So, if you don't know what MS is, it is a partially silver mirror. Anything that lands on any light source that lands on the silver part gets split into two. Okay, so we set up the whole experiment, and it's ready to go. So the light source goes to the mirror, and it lands on the partially silvered part, splitting it into two. Those two light sources, well, now they have their own mirrors in front of them, reflecting them back to get on the regular side, which combines them into the one light source we had before, and then goes to the detector to set it off. And that is the Michelson-Morley experiment. Step 2, a boat analogy. Since this is very hard to understand, I'll give you another glance of it. Imagine a boat. So there are the 3 docks. Dock A, Dock B, which is in the top left corner, and Dock C. doc C. Doc C, which is in the bottom right corner. Now, what is the path to get from doc A to doc B? 1, 2, or 3. We have to choose one. Also, don't forget about the V or ether. It is going from west to east. But anyways, it's 1 because if we go this way, the V will pull us this way. So we're on doc B. Now, in order to get from doc B to doc A, which path do we choose again? 1, 2, or 3? Still 1. Because if we go this way, then V will pull us this way. So we will go this way. And that is our boat analogy. Also, don't forget that A is pretending to be MS, B is pretending to be M1, and C is pretending to be M2. Alright. So, this way is downstream. And this way is upstream. MS to M2 is this length, and MS to M2 is also this length, which we will call L2. Step 3, MS to M2 and M2 to MS. So keep in mind that MS to M2 is downstream and M2 to MS is upstream. Okay. So distance is L2, and the velocity, since we're finding T2 here, is well C plus V, because you're going upstream. So the V or the ether fastens you up, like the gravitational push you get from Jupiter when you pass. But M2 to MS changes the velocity. D is still L2 because the length is the same. But look out! V is C minus V because you're going upstream, not downstream. So the ether will slow you down eventually. Also, we're using C because that's the top speed you can go. Okay, now let's see what T2 is. So with all our information, T2 ds is L2 over C plus V, and T2 US is L2 over C minus V. Now, T2 ds plus T2 US is L2 over C plus V plus L2 over C minus V. We have to multiply this fraction by C minus V and this one by C plus V in order to get a common denominator. So that will be L2 C minus V plus L2 C plus V over C plus V C minus V. Now we distribute everything, literally everything. Okay, that will make L2C minus L2V plus L2C plus L2V over C squared minus V squared. Now you obviously know that L2V, L2 minus L2V cancel. So that leaves us with 2L2C over C squared minus V squared. But now that leads to taking Barney. What do we do now? Well, we have to factor out C squared from the bottom. So that is 2L2C over C squared, 1 minus V squared over C squared. Because, we don't know what we will reveal V and C much further in this interferometer. So C goes to C squared C times. So T2 is 2L2 over C, 1 minus V squared over C squared. Now we are on step number 4. Okay, step 4. Okay, so M1 is M1, as you can see here and here. But also, if you haven't noticed, the concept of upstream and downstream is thrown away to the garbage heap because the upstream and downstream deals with the horizontal line, or X, while we were focusing with T1, deal with the vertical line, or Y. So the downstream and upstream concept is crossed out today. T1 is L1 over, we know D is L1, and we know V is V naught, but what is V naught? This is where we started from, in the boat analogy. And that's right. We were trying to go this way and twist 1. So let's put a thing there, and let's call it C, because that was our velocity. And then V was going this way. So let's make this line and name it V. That leaves this line, this remaining line, called V naught. So A squared plus B squared is C squared, right? But we don't need that. We need B. So B squared is C squared minus A squared. That means V naught squared is C squared, because the hypotenuse is C, minus V squared. So V naught must be the root of V naught squared. Or to go further, the root of C squared minus V squared. Okay, so now we have found out the way, that way. Okay, don't get triggered. Okay, so L1 over the root of C squared minus V squared. Okay, so now we must find the real T1. Okay, so 2T1 or T1 plus T1 is L1 over the root of C squared minus V squared plus L1 over the root of C squared minus V squared. You might know that is 2L1 over the root of C squared minus V squared. But now you will ask again, Barry, what do we do now? Well, see this root? We can still factor it inside the root, but we'll have to split root. You know what I mean. So 2L1 over the root of C squared 1 minus v squared over c squared. And then they have to split root. You know what I mean, okay? Okay? So 2L1 over the root of c squared and the root of 1 minus v squared over c squared. Square root cancel. OMG! Square and root make square root, so they really do cancel. Whoa, whoa! Oh, whoa. 2L1 over c times the root of 1 minus v squared over c. Okay, step 5. Number 5. This is where the change of t comes in. Okay, so let's make an assumption. L1 is equivalent to L2, and L2 is equivalent to L. Since L1 was equivalent to L2, and L2 is equal to L, that means L1 is also equivalent to L, because L1 was equivalent to L2, and L2 was equivalent to L. So that means L1 must be equivalent to L2. So that means the L1 and L2 gets replaced with L. So now, T1 is equal to 2L over C times the root of 1 minus v squared over c. Man, I'm saying root too many times. You might get it confused. And I already said, you might get it confused with the root of a tree. Ha! And T2 is now 2L over c, 1 minus v squared over c squared. And now, here comes the change of t. The change of t is t2 minus t1. And you may know. So, that is 2L over c times the root of 1 minus v squared over c squared minus 2L over c 1 minus v squared over c squared. Seeing that, we can see, oh wait, no, it's this way. Sorry, my bad. Okay, so now you'll say, Bob, what can we factor out? Well, we can factor out 2L over c. That leaves us with 1 over 1 minus v squared over c squared, since 2L over c goes to 2L over c one time, minus 1 over the root of 1 minus v squared over c squared. Because again, 2L over c goes to 2L over c one time. Okay. Okay, step 6. Anyway, step number 6. 0, then the change of t is 0. Then that means that the two beams will return in the same phase. If you don't know what that means, I'll give you an example. Let's draw this wave. A nut and B nut, A prime and B prime are in the same phase. If V is not equals to 0, that means there is an ether. And that means that the change of t is not equal to 0. So that means the two beams are out of phase. Out! So, if you don't know what out of phase means, I'll draw our wave again. A prime, B prime, and C. So, imagine A and A prime. These two are out of phase, as well as B and B prime. B prime and C are also out of phase. Now, let us do our math solutions, our techniques, and our consequences. Okay, our problem is that we cannot stop our lovely Earth from moving, because firstly, the Earth is sufficiently large, so we have no idea how to stop it. Secondly, if we build somehow built some giantly dingy of some sort, then the Earth is moving at 3 times 10 to the 4th meters per second, which is just the speed of light, except the exponent is changed. The exponent, not the exponent. Sorry, my axe. Our solution is that we can use our Michelson-Morley experiment that we drew all the way at the beginning. And the technique is to find an apparatus and rotate it 90 degrees. And you know what it is. It's a right angle. It's a right angle. Okay, so our consequences is that reverse T1 prime, or the reverse T1, or T1, T2. T1 is, well, as you know, 2L2 over C times the root of 1 minus 3/4 over C. Okay, I think I should stop saying root because you might get it confused with the root of a tree. T2 is 2, oh wait, T1 is 2L1. Sorry. T2 is 2L2. Silly mistake. 2L2 over C, 1 minus 3/4 C squared. Okay. And here are the reversed ones. T1 prime is 2L1 still, but over C, 1 minus 3/4 over C squared. L1 is equivalent to L2, but in this case, T doesn't involve the root. Okay, step 7. If you don't remember, delta T is T2 minus T1, and delta T prime is T2 prime minus T1 prime. You go do the math after I explain this part. I'll wait for you. Delta T is T2 minus T1. That is 2L2 over C, 1 minus 3/4 of C squared, minus 2L1 over C times the root of C squared minus, oh wait, 1 minus 3/4. Also, should I start saying root? You might get confused. You might get it confused with the root of a tree. Oh my God. So anyway, this huge whole thing is we can factor out 2 over C and L1 plus L2. That is a lot, isn't it? But it's not. What is left from that is probably delta T not. Oh wait, delta T prime. I always get that. That always gets me. Sorry. Okay. So that will be 2L2 over C, 1 minus V squared C squared, minus 2L1 over C times the root of 1 minus 3/4 C squared, parentheses, minus, parentheses, 2L2 over C times the root of 1 minus 3/4 C squared, minus 2L1 over C, 1 minus 3/4 C squared. This is a very big monster line. So let's shorten it. So we'll factor out 2 over C and L1 plus L2. The things remaining are 1 over 1 minus v squared c squared minus 1 over the root of 1 minus v squared c squared, right? Okay, so if, let's make a subset. If v over c is less than 1, then 1 over 1 minus v squared c squared can be equal to 1 plus v squared over c. So let's write that. And 1 over the root of 1 minus v squared over c squared can also be rewritten as 1 plus half v squared over c squared. Okay. Now, 2 cancel and 1 cancel, leaving us with, wait a sec. No, not yet. So 1 minus half is half. So we will draw that. Okay. So 2 over c, L1 plus L2, and then 1 minus half is half v squared over c squared, and then 2 cancel, and then c times c squared is c cubed, leaving us with our legendary equation. L1 plus L2 and v squared over c cubed. Okay, step 8. Active Earth, as you just witnessed, is 3 times 10 raised to the 4th. And c, or the speed of light in a vacuum, is 3 times 10 raised to the 8th. Now, let's use our equation. So that's 11 plus 11, and then 3 times 10 raised to the 4th squared over 3 times 10 raised to the 8th cubed. Okay, so so distribute the exponent. So that's 22 times 9 carried to the 4 to 8 over 27 times 10 raised to the 24th. Okay, so 9 goes to 9 1 time, and 27, 9 goes to 27 3 times. And also, so that's 22 times 1/3, or 22 times 0.33 times 10 raised to the 8 minus 24, or minus 16. So that's 7.26 times 10 raised to the negative 16. Okay, step 9. Visible light is 5.5 times 10 raised to the negative 7. And C, as you just witnessed, C, with the speed of light in the vacuum, as you just witnessed, is 3 times 10 raised to the 8. But what is frequency? Frequency is C over lambda, or 3 times 10 raised to the 8 over 5.5 times 10 raised to the negative 7. So 7 comes up on, becomes part of 7. So that's 0.5 to 14. step 10. Last step before the finale. Okay, step 10. T is 1 over F. That is 1 over 5.5 times 10 raised to the negative 14. Raised to the 14. Estimated to 1.8 times 10 raised to the negative 15. Okay, step 11. So we divide this by this. Okay, so number of friends is t lowercase t for time over capital T for period. Okay, so that is 7.26 times 10 raised to the negative 16 over 5.5 times 10 raised to the 14. Okay, so estimated to point was 3 friends. Well,
Now explain. Explain the result.
wait. That, but the scope was up at 0.01 friends, but they couldn't see. So they rejected the idea of the imaginary ether. Actually, you spell it like AETHER.